So now we're going to do some example problems from section 4.3. The first thing is to find six trig functions for theta given this triangle. So the thing we're going to need is the hypotenuse. So 12 squared plus 18 squared, let me take the square root, we get the square root of 468. With a little bit of work, we can reduce that, and it reduces to 6 root 13. Okay? So then, we're going to find the sine, cosine, tangent. You're going to match these up with their reciprocal, cosecant, there we go, reciprocals. Because once I find these three, I can just flip them to find the other ones. I'm going to have to rationalize any radicals, right? So sine would be, of this would be opposite over hypotenuse, or 18 over 6 root 13, which means that the cosecant would be 6 root 13 over 18. Now, unfortunately, I'm going to have to rationalize the sine, which means I multiply by the square root of 13. So I'm going to get 18 root 13 over, well, 6 times, because when I multiply by root 13, we get 6 times 13, which is 60, plus 18, or 78. Cosine, similar, except it's going to be 12 over 6 root 13, which means I'm going to have to rationalize it as 12 root 13 over, well, 6 times 13, we already know is 78. Here, I'm just going to flip the original, so it's 6 root 13 over 12. Thankfully, 18 over 12, which I know is reducible, but I'm just going to leave it, meaning this is 12 over 18, and that's it. So, in this, find the exact values and explain why the function values are the same. So, to do this, what I've already done is I figured out that this was the square root of 189, aka 3 root 21, and this is the equal to, well, 2 root 21 in the end. Now, I'm going to go ahead and get ahead of this. Why are they the same? Well, it turns out that these triangles, if you look at this ratio, so if I take the ratio of hypotenuse to a hypotenuse, 15 is to 10, as well, this is the opposite of theta, so these correspond to 6 is to 4, as 3 root 21 is to 2 root 21. Turns out that all of these, when you reduce them, are 3 halves, which means this is the common scale factor between these. So these are similar triangles, which, as you know from geometry, means all the angles are the same, which is why when you're finding the sine, the cosine, and everything like that, they're going to be the same, because really this is the same angle. So then we just repeat what we did in the last problem, except with different numbers. Well, let's go with this, because I think it'll be easier to reduce. So sine is going to be 4 over 10, aka 2/5, which means that the cosecant is going to be 5 halves. Just take reciprocal. Cosine will be 2 root 21 over 10, or root 21 over 5, which means that the secant, get rid of this straight mark here, the secant is going to be 5 over root 21, which is 5 root 21 over 21. And the tangent is going to be opposite over adjacent, 21, aka 2 over root 21, which is 2 root 21 over 21. And the cotangent, well, I'm going to flip this one because it's going to be the easiest, because then I won't have to rationalize anything. That's it. So, sketch a right triangle, and then use the Pythagorean theorem to find the third side, and then find the values of the other 5. Okay, well, let's go with this. Cotangent of theta equals 5 over 1. It's helpful to think of this as a fraction. So, this means we have theta, this is 5, this is 1, 5 squared plus 1 squared is square root of 26. And then we can find the tangent, as we have the cotangent, that's 1 over 5. The sine would be 5 over root 26, or 5 root 26 over 26. 26. The cosecant would be the reciprocal, aka root 26 over 5. The cosine would be 1 over root 26, or root 26 over 26. And the secant would simply be root 26 over 1, or just root 26. Similar process here, except it's the cosecant. Remember the cosecant, well, let's figure out, this cosecant matches to sine. Let's figure out the sine, which is 4/17, right? So if we're looking at the sine of 4/17, that means here's theta, that's 4, that's 17. And with a little bit of work, we can discover that this is the square root of 273. It turns out to be non-reducible, which is really exciting, isn't it? So that means what? That the tangent of theta is 4 over root 273, aka 4 root 273 over 273. And it means that the cotangent is easier because it's going to be the other way. It's going to be root 273 over 4. The cosine, which is all we have left, is root 273 over 17, which means that the secant is 17 root 273 over 273 after you rationalize it. Okay. Construct an appropriate triangle to complete the table. Okay, secant. Theta in radians is pi over 4, so that's 45 degrees. 180 divided by 4. What's the function value? Well, the secant of 45 is the same as 1 over the cosine of 45. Well, the cosine is, 45 is root 2 over 2, so this is the reciprocal of that, or 2 over root 2, which we rationalize. And we get 2 over 2, which is, you guessed it, root 2. Fundamental trig identities. Remember, this is the relationship. Cosine of 90 minus theta, what corresponds? That's equal to sine of theta. Cosine matches with sine. Cotangent matches with its cousin tangent. And cosecant matches with secant. Simple. As long as you remember what the relationship is. Cosine with sine, cotangent with tangent, cosecant with secant. And this works both ways. Okay. Use the function values in the trigonometric identities to evaluate each trigonometric function. Okay. So you know that the secant is equal to 5, aka 5 over 1. Cosine is the reciprocal of that, so it's equal to 1 over 5. Now, tangent is equal to 2 root 6. So that means cotangent is 1 over 2 root 6. In other words, the reciprocal, which we multiply by root 6. We get root 6 over 2 times root 6 is 12, right? Here's where it gets fun. Cotangent 90 minus theta. Hey, wait, that's the same as the tangent, so it's just 2 root 6. Sine. Uh-oh, we're going to do some work here. So if the secant is equal to 5 over 1, or the cosine is 1 over 5, that means we're looking at an angle where the adjacent is 1 and the hypotenuse must be 5. And for the tangent to be 2 root 6, guess what? Opposite or adjacent, so that's 2 root 6 over 1, which means the sine of theta has got to be 2 root 6 over 5. We could have just drawn this in the beginning and figured all this out, and that would have worked just as well. So let's try that this time. If we know the tangent of beta is 3, that's the same as 3 over 1. So we know we're looking at a triangle. And this time it's beta. It's just another name for a variable, right? Is 3 over 1. 3 squared plus 1 squared is the square root of 10. So what is the cotangent? Well, it'd be the reciprocal, or 3. What is the cosine? 3 over root 10. Move this out of the way a little bit. Right. 3 over root 10, which would be 3 root 10 over 10. Tangent is equal to the, what's the tangent? 9 is equal to the cotangent, so that's equal to 3. Cosecant is 1 over the sine, So the sine would be 3 over root 10. So that means that cosecant is root 10 over 3. So, finding special angles. Find each value in degrees and radians without using a calculator. So the cosecant, or 1 over the sine, is equal to 2 root 3 over 3, which means that the sine is equal to, I take the reciprocal, 3 root 3 over 2. Oh, that's wrong. Sorry, I misspoke. 3 over 2 root 3, which means I can multiply by root 3, multiply by root 3, 3 root 3 over 6, aka root 3 over, that should look familiar. When is the y value equal to root 3 over 2? That's when theta equals pi over 3, aka, so that would be radians, or 180 divided by 3, 60 degrees. Sine is equal to 1/2. Theta equals, well, pi over 6, or 30 degrees. We know this from our knowledge of the unit circle. Same idea here. If the cotangent is that, what does that mean the tangent is? That would be 3 over root 3, yes? So that would be 3 root 3 over 3, or root 3. So when is the tangent equal to root 3? So this is one of those situations where we're probably looking at something like the square root of 3 over 2 over 1/2, because when you divide that out, you do get root 3, which means that we're looking at sine over cosine. So we know that the sine of theta has got to equal root 3 over 2, which means that we're looking at theta being equal to pi over 3, or 60 degrees. Secant, same idea. That means 1 over the cosine, or the cosine is equal to 1 over root 2, which is the same as saying root 2 over 2, which corresponds to pi over 4, or 45 degrees. Find x and y. There they are, right there. See? See? Or, if we set this up, so we know that the sine, let's say, the sine of 30 degrees is equal to y over 15. Well, the sine of 30 is known. What's the sine of 30? That would be 1/2 is equal to y over 15. Multiply by 15, y is 15 over 2. Cosine of 30 is equal to x over 15. Cosine of 30 is root 3 over 2. X over 15 multiplied by 15, so 15 root 3 over 2 is x. We leave it. It says it's exact, we're going to leave it like that. No decimals. Okay? Now, this last one. Find the angle of elevation. So the angle of elevation would be measured from the horizontal, so it's that. Which means that, now we only know these, which are opposite and adjacent, so it's the tangent of theta is equal to 50 over 50, aka 1, which means that sine and cosine must be equal, which only happens when theta is 45 degrees, right? So that would be the angle of elevation, would be 45 degrees. The other way to look at this is an isosceles right triangle. It's got to be 45, 45, 90, right? Find the number of feet of steel cable needed for the zip line, which I would argue is this bit here. Yep, sliding down a zip line straight down is not a good idea. At an angle is much better. So that would mean that length, we call it, is the square root of 50 squared plus 50 squared, which is the square root of 2,500 times 25 plus 2,500, which is the square root of 5,000, which when you reduce it is about 50 root 2, which is about 50 times 1.4, which is right around 70 feet. And that's it.